Taking a look at example 4 on page 545, we have a right triangle, and I'm going to draw it for you. It has a hypotenuse of 12, and it has a leg that's 9, and here's my angle, my theta. And it wants us to solve for the angle theta, so it's just asking us to find that angle. Now, what you have to do when you're looking at these is first you have to identify which trig function you can use, your sine, your cosine, or your tangent. So when I look at this angle is beside this 9, so this is the side that is adjacent to that angle. This one would be the one that was opposite, and this is the hypotenuse of the whole triangle. So remember that if the leg that is beside the angle is not the hypotenuse, it's the adjacent. So for this angle, I happen to have the side that's adjacent and the hypotenuse. And remember that sine is side opposite over hypotenuse, cosine is side adjacent over hypotenuse, and tangent is opposite over adjacent. So once you know what pieces you have, you can pick the correct trig function. So I know that the cosine of my angle is equal to the side adjacent over 12. So if I knew the inverse trig function of 9 over 12, I would have my angle. So all I need to do is take my calculator and hit the inverse trig function by hitting the second function key and the cosine, and it's going to open up a set of parentheses, and you're going to need to type 9 divided by 12 in there and close the parentheses and hit enter. Now, you need to be careful about whether you want the radians or whether you want degrees. I have my calculator set in degrees right now, so it is telling me that my angle is approximately 41.4 degrees because my calculator is in degrees. So you need to make sure that if the problem is asking for degrees, you make sure your calculator is in degrees. If it's asking for radians, you put it in radians. Now, this particular problem didn't tell you how they wanted it, so you just need to make sure that you put your notation and told what your answer was in. So that's how you do those.